The table below shows the population growth of the zebra mussels in a local recreational area. Identify the independent and dependent variables. Is there relationship in the data? And if so, predict the number of zebra mussels in 2039. Now, I'm going to tell you right up front, in order to do this problem, the way that we're going to do it, you are going to need access to a graphing calculator. We're going to do this on a graphing calculator. So you will need to have one of those handy, and you're probably going to want to write down the steps that I'm going to do, the buttons that I'm going to press, because there are quite a few. And you're going to want to have these written down so that whenever you go back and do one of these yourself, you know which buttons need to be pressed to create. I'm just going to tell you, we're going to create a scatter plot. We're going to graph it on the calculator after we put in this table to the calculator. So I'm going to show you how to put a table into the calculator and graph it. And then the calculator can actually find an equation from a table. Now, the table's not going to be perfect. It's not going to be perfectly straight. So the calculator finds what is called a best fit line, a line that goes through the points the best, goes right up through the middle of the points. And then we're going to use that equation to answer the question, what is the number of zebra mussels that we predict in the year 2039? The first thing we can do without a calculator, though, it says identify the independent and dependent variables. Independent means the x, dependent means the y. 999 times out of 1,000, X is on the top and Y is on the bottom, and years or time in general is pretty much always the independent variable. It's hard for time to be dependent on anything. So time is going to be independent, and and number of mussels is going to be dependent. Now that's important to us because whenever we put this into the calculator, we're going to put years into our X and we're going to put number of mussels into the Y. Okay, so everything else we're going to do here is going to be done on the graphing calculator. So if you need to, pause the video and get your graphing calculator out and go ahead and turn it on. And so here's what we're going to do on the calculator. The first thing that we're going to do is we're going to put this table into the calculator. So to put a scatter plot, a table to make a scatter plot into the calculator, the button we're going to push is the Stat button. It's right below the Delete key. You can see it's got a little red ring around it on my screen. So we're going to select Stat, and then I'm going to press you can press Enter or you can press number 1 to select Edit. So Stat Edit is going to take us to this screen that's got L1, L2, L3, L4. So stat and then the number 1 is what I pushed. L1 is where we're going to put all of our X values. And the X values for this problem were just 1 through 7. So I'm going to do 1, 2, 3, 4, 5, 6, 7. I'm pressing Enter after each number. Okay, so there's 1 through 7 for our X's. And then I'm going to arrow over to the L2 column, and that's where I'm going to put the Y's. So I jotted the Y's down on a piece of paper so I wouldn't have to flip back and forth between my notes and the calculator. So I'm going to put the Y's in real quick. 15, 125, 175, 225, 325, 435, and 483. Okay, so I have the independent variable, which was year since 2039. Year since 2009 in the X column, L1. And I have the dependent variable, which was the number of zebra mussels in L2, which is my Y column. Okay, so the first thing I want to do is I want to graph this. Now, that is not just pressing the graph button, because the graph button graphs equations, and I don't want to graph an equation, I want to graph a scatter plot. The way I put in the scatter plot was by pressing the Stat button, so I want to do what's called a stat plot. And if you look at our y equals button on the calculator, you can see in blue right above y equals, it says stat plot. So I'm going to press second and then stat plot. And right there at the top, it says plot 1 off. So I'm going to press enter to select plot 1, and I'm going to turn plot 1 on. I don't need to change anything else on here. The type is what type of plot I want to do. And we've got histograms, box plots, all kinds of stuff. But the first one that's selected there is the scatter plot, and that's the one I want. And then by default, it has the X list is L1 and the Y list is L2. Remember, I put the X values into L1 and the Y values into L2. You can change the mark. That means, like, what do you want the dots to look like? So if instead of squares, you want to do a plus or something, that's fine. doesn't matter. I'm just going to leave it as the default square. Now I'm going to press graph. Now I don't see anything on here, and that's because by default, my graph goes from -10 to +10 on the X and Y axis. And my first point was 115. So my first point is going to be up higher in the first quadrant than what I can see. Okay, so I need to change my window. So I'm going to press my window button. My X's went from 1 to 7. My lowest X was a 1 and my highest X was a 7. I'm going to make my minimum X 0 and I'm just going to leave my maximum X as a 10. I could go from 1 to 7 since that's where my X's were, but then the first point and the last point would be right on the edges of the graph and would be a little difficult for me to see. So I'm just going to go 0 to 10. That'll show me the Y axis and it'll give me a little space on the edge where the highest X is. Scale is what you want each line to be worth. I'm just going by ones is fine. Now my Y's, the lowest was 15 and the highest was 483. So let's just make our Y's go from 0 to 500. I can make the Y scale stay at 1, where each line on the Y axis is worth 1. It doesn't really matter. I don't care what the scale is, but I'm just going to make them go by 50 just so it looks a little nicer. So each line on the y-axis is 50, so it's going to go like 50, 100, 150, 200, and so on. Now I'm going to graph it. So I press the graph button, and there's our scatter plot. And now that we can see our scatter plot, it's pretty obviously a positive correlation. Great. What is the equation of the line that goes through those points? Well, there is no line that goes exactly through those points because those points are not in a straight line. But I can do what is called a best fit line, and that is a line that goes as close to those points as possible. I want a line that's going to go right up through the middle of those points. And the calculator can actually find that best fit line for us. Again, we're going to go to our stat menu. And this time we're going to arrow over one time so that we're looking at that calc menu. So stat calc. The calculator does not call it a best fit line. The calculator uses the sort of highbrow math term for it, which is linear regression. And that is this fourth option right here. And you can see that it uses AX plus B, which reminds us a lot of MX plus B. So that's the one we want. We want to select linear regression, and we'll go ahead and press enter. And by default, it says the X list is going to be L1 and the Y list is going to be L2. Now, if I just go down here and go to calculate, it's going to tell me the equation, the best fit line equation. It's Y equals AX plus B. And it says the A is 77.64 and then a whole bunch of numbers. I'm just going to round it to 77.64. And the B, the y-intercept, I'm going to round to -55.86. Okay, and I'm going to jot these numbers down. So now I'm going to graph this. So on my calculator, I'm going to press y equals, and I'm going to graph y equals 77.64x minus 55.86. And there it is, right up through the middle of my points. That's my best fit line. Okay, now if I go look at my table, the table is, of course, not going to have exactly the same points as my scatter plot did because the line is not perfectly going through those points. For example, my first point was 115 and the table is 121.78. My second point on the table was 125, and the equation gives me 99.42. It's off by a little bit because my points were not in a perfectly straight line, but it's pretty close. It's as close as the calculator can get. Now the question was, how many mussels do we expect in 2039? So let's go back and look at our table, which said years since 2009. So there's a couple of ways we can do this. Our equation that we came up with was y equals 77.64x minus 55.86. One of the things we could do is we could just plug 30 in here. 2039 is 30 years since 2009. So that's one thing we can do. And we can use the calculator to tell us what that would be. But another thing we can do is if we go back to the calculator, we could also just scroll down until we get to x equals 30. 2273.3 is what we get when we have x equals 30, and that is 2273.3 is what we would get if we plugged in 30. Now we can't have 0.3 zebra mussels, so we're going to say in 2039 we'd have about 2,273 zebra mussels. Okay, so we used the calculator to create the scatter plot. We saw the scatter plot had a positive correlation, which is why our best fit line ended up having a positive slope. We used the calculator to create the best fit line, and then once we had that best fit line, we used it to make a prediction. Now, you can stop the video right now. This is all that you need to know. But if you want a sort of advanced calculator trick for this, I'm going to give you one little advanced calculator trick. It'll take me about 45 seconds to show you. Our equation here was rounded. 77.64 was rounded and negative 55.86 was rounded. It turns out you can actually put this directly in the calculator without rounding. If we go back to Stat Calc 4, right here, there's a spot that says Store Reg EQ. So I'm going to go to y equals and I'm going to clear this out so that the equation's gone. I'm going to do Stat Calc 4, go to Store Reg EQ, then press vars, go to yvars, select function, and right there is y1. So now when I do calculate, it gives me the best fit line equation, but when I press y equals, the equation has been automatically plugged in unrounded. So now when I go look at the table, it gives me about the same answer, but it's not a rounded answer. So this is if you're super lazy and you want to have it just plug the equation into the calculator for you, the calculator can do that as well. Whenever you are doing the regression, you can say, hey, do the regression, and then go ahead and put the equation in y1 for me. It makes a very, very slightly more accurate graph.